Hello everyone and welcome. So today we'll be looking at the solution video for the foundation track of the last challenge, that's January 2026, and the title of that was The Mysterious Slowdown. So, okay, so first of all, thank you, everyone. I think I got some feedback on the last video to remove the background music, so I'm going to do that for this. So you must have noticed there's no background music here now. So thank you for the feedback. You can let me know, just let me know in the comments if there are any things you need maybe should change or something, and I'll try to incorporate that. Thank you. So a new branch office is online, but performance is catastrophic. Pings are intermittent, applications are timing out, and a recently added backup link seems to have made things worse. As the lead engineer, you must perform a full network audit, diagnose all performance and routing issues, and restore stable, optimal connectivity. So you can go through all of this. So the topology. So let's just add these VPCs to this topology. So add new node. I'm just gonna bring in two. Yeah, port one of the switch, and this right here also goes to port one of the switch. We can just rename this to branch PC, and this to HQ PC. Okay. So let's power on the devices now. Start all nodes. Yeah. Okay, so we know it's essential to go through this because there are some important information you might need in the lab there. You might need some important information to maybe to just reference an IP address or something. So it's essential to go through that. Okay, so before you start, connect the NPC as shown in topology and set this IP on it. So for the branch this, for the HQ this. So let's just do that before we start. Let's just do that. So this is the HQ PC. So IP 192.168.20.100 24, I think 55 is the subnet, and 192.168.20.1. And let's do similar for the branch. IP 192.168.10.100, subnet 255.255.255.0, and the gateway 192.168.10.1. And that should be fine. Okay, so that is applied. Okay, so let's console into the devices now. I just like to arrange mine this way. Okay, the HQ, and the HQ switch, the HQ router. I just like arranging it as the topology is, so that's going to kind of be cool. Branch. Okay, so I think this is fine. I think this is fine. So now let's go ahead. So users at the HQ PC are reporting intermittent connectivity failures, especially when new devices are connected to their PC. So logs on this show some security violations. Investigate the HQ switch to resolve this issue. So this is the HQ switch. Let's see what's going on there. The HQ switch. I'm just going to do a quick show run to see what we have that can be causing this issue. It says users when new devices are connected, so they're to this switch, they are getting this issue. Um, okay, and now we see on this port one of this switch where device is connected to, we are having some restriction there. We're having some restriction there. So we can remove this security. We can remove this security, this port security, or we do something. Let's do something. Let's go to this interface E01 and this port security. Let's see. Port security and maximum one. So using maximum of one, let's show run again. Showing run again, we see that using maximum of one, there is nothing. So by default, it is one. So if a new device tries, maybe we remove this PC now, remove that PC, and a new device tries to come to register its mark, it's not going to be possible. So if we change it to two, we should be able to see the configuration there. So if we want to keep this, we can maybe increase it because it's for security. We can increase it to a certain number, maybe 5 or 10, depending on the number of devices that we plan that can maybe switch something like that, or it's just removed. It is just removed. So we can just keep it at maybe 5. We can keep it at maybe 5 for now. Okay, so keeping it at 5, what happens is that this interface, so this device can accept up to 5 MAC addresses, can lend up to 5 MAC addresses. If this PC is removed from here and another unique PC is brought here, it's going to accept it. It's not going to refuse it from connecting. By default, it is one. By default, it is one. So if a PC is connected and we remove it and try to connect another PC, it's not going to work. The switch is not going to allow it. And in the last video, I showed us how to record our answers. Let's just try to do that again. I showed us how to record our answers. So let me just paste this. Okay, so what prompt was that? That was 1.1, right? Okay, so we can just maybe copy that over here. Then I think that was HQ switch. Yep. So the issue was that port security was configured and allowing maximum of one unique MAC address. So that was the issue right there. So to fix that, we ran some commands, config t, we went into the interface E01. What else? What did we do? We did switch ports, right? We did switch port security, and I don't know how to spell security. Okay, and we did maximum. We just changed it to 5. That's fine. If you decide to remove the switch port totally, I would still accept that because well, it fixed the issue. It removed the security, but I did not explicitly mention that don't maybe bypass the security, keep the security functions or things like that. So if you increase it, the question is quite vague. It did not specify exactly what to do. So if you increase it, like the maximum allowed, fine. If you decide to maybe remove that, it's also fine. But this is how to log your answer. So you do that for all the prompts because you're only going to submit this. You convert this document to a PDF and submit that PDF. Okay, so 1.2. Why troubleshooting? You notice that some return traffic destined for the branch PC is being dropped at the branch switch before it reaches the user. Investigate the configuration on branch switch. So let's check the configuration on branch switch. Okay. My eyes is spotting something, but let's see if something else. I don't know why this is disconnecting. I don't know why it's doing this. On the branch PC. Okay. So see that VACL we saw earlier is bound to this subnet. It's bound to the subnet of the PC. We saw the subnet earlier. This is the subnet of the branch PC. It's bound to this subnet. And at the end, we saw something. We saw something at the end. We are saying action to prop. So let's see. This PC should be able to reach its gateway, right? If the gateway is up, it should be able to reach the gateway. So I believe this switch is the gateway. Let's confirm. Let's just increase this. Okay, so the switch is the gateway 10.1 and it's up. So let's try to reach the gateway. Ping 192.168.10.1. And we see it's even an issue. The switch cannot reach its gateway. Let's check if the VLAN 10 is passed on this is 0/1. 0/1 show run. Yeah, it is passed. So we see that VACL we saw earlier is doing some stuff we don't like. It's dropping that traffic because of this action right here. Drop. So let's explore what we can do from this. Let's explore what we can do with that. Config. So we have the action. Let's see if we can have other actions. So let's forward this packet and let's see if things change. And beautiful, we can now reach it. So the issue was that VACL. It was that VACL. This is like a layer two. This is like a layer two ACL. So we see VLAN access map and all of that. So it's kind of dropping the stuff from the layer two. So with that, we've been able to fix this issue because yeah, I think that's what this prompt is all about. Okay, so 1.3 new devices. Of course, when you do this, you have to document it because this is the only documents that are going to be submitted. 1.3 new devices on the branch PC's VLAN are failing to obtain an IP address from the TCP server. Oh wow! So this is even a mistake. I shouldn't have put this IP here. I should have stripped this off. I think this was from the last challenge. So these devices are not supposed to have a static IP. So they should use DHCP. So let's fix that. So there's IPDHCP, right? Yep. So now it's trying to perform the DORA, the discover, offer, request, acknowledge. But you see, it's being stuck at the discover. It's trying to locate the DHCP server, but it can't find the DHCP server. So let's try again. So we see it cannot find the DHCP server. But here they're telling us that what the DHCP server is at HQ. So let's even see if the PC at HQ can find the DHCP server. Let's see if that side is also having issue. Oh, I think something is fine here. So we see we can complete the DORA, discover offer request acknowledge, and we are getting IP. Let's see if we can reach the gateway, which we should. If everything is cool, okay, we can reach the gateway. So this is what I can understand from this. This HQ router is the DHCP server for the HQ PCs and the branch PCs. Now the HQ PCs are getting IP, but the branch PCs are not getting IP. So let's dive into that and troubleshoot. Okay, so we know that what we're having here is a kind of layer 3 connection already from the HQ to the HQ branch here. We have a layer 3. From here to here, we have another layer 3. So we should be talking about a form of relay going on here. So who is the gateway for this branch? It's the switch, right? It's the branch switch. Let's confirm. Let's verify once more. Do show IP interface brief, and we see that the switch is the gateway, VLAN 10. So we should be trying to do some form of IP helper on this VLAN 10 because that's the gateway. Let's check what we have. Let's check what we have, whether it is there, and we can see it is not there. But what's this? We can see we have this. I think this must be a misconfiguration. It is misconfigured on VLAN 1. And let's just confirm. Is VLAN 1 doing anything? I guess not. VLAN 1 is not doing anything in this network setup. So we see that is a misconfiguration. This is supposed to be under VLAN 10 and not VLAN 1. So let's just fix that quickly. So interface VLAN 1, no this. Now this 10.20.20.1, let's even confirm that that's a proper IP we should use. Let's check the HQ router. Show this 10.20.21. Okay. 10.20.20.1. So I think that's fine. I think that's fine. So that's that. And if we check this HQ switch, I believe there's also a form of relay. A form of relay should be going on here also. And let's see. Oh yes, this right here. A form of relay is also going on here because the connection between this switch and this DHCP server is a layer 3. The PC cannot directly see the DHCP server. They are on different subnets. The DHCP server is 10.20.20. Something, while the PC is 192.168. So they are on different subnets. So there has to be a man in the middle, a guy that's going to relay, that's going to pass the ball, like the midfielder. No, the defender cannot just pass the ball directly to the striker. Well, they can, but right here, we need a midfielder so that the defender passes the ball to the midfielder and the midfielder gives a type of Iniesta or Xavi assist to the striker and the striker scores the goal. So that's what is going on right here. So let's just quickly fix the branch. So we've removed that from VLAN 1. So let's go into VLAN 10 and paste that right there. And let's try our DORA process again on the branch PC. Not finding the server. Okay, let's try that one more time. Okay, it still cannot find the server. Okay, so let's try to do something. So let's see if the branch switch can reach this DHCP server, right? Let's know if we can even reach the guy we are trying to say is the server. And oh, the success rate is 0%. So we can't even reach that server. So I think we need to still do some stuffs. Let's just move ahead. Let's move ahead. I think there is no connectivity. Show routes. Is that the command? No. Show IP routes. Okay, this is using a default route. Let's check the branch router and see if there is a route to 10 dot to what? 10.20.20.1. Okay. Show. Why am I just using show routes? So right here we can see on the branch router we are learning that network via OSPF. We are learning via OSPF. Let's see if we can reach it from here. 10.20.20.1, and we can reach it from here. So there is something there's probably something that is making um there's something making the branch switch not able to get that. So what's the connection between the branch router and the branch switch? I think they are using static routes, right? They're using static routes. So default route to 10.10.10.2. Let's see. Show IP interface brief. Okay, so 10.10.10.2 should be the other guy, should be the router. But it's unreachable. Why? What's the router's IP? Show IP interface brief. 10.10.10.2, right? So why is it unreachable? Try to ping the switch. Also can't ping the switch. So there should be an issue going on here. Okay, let's continue with what we have here. Let's continue with what we have here so that when we get that issue, we can document it properly under the correct prompt. Okay. Mm, the primary OSPF between branch router and HQ router over the ISP link is not forming. A debug reveals the problem, so identify and fix the issue. the HQ router and the branch router, the OSPF is not forming. Okay, so let's check that. Let's check that. So on the branch, show IP OSPF neighbor, right? I think that's the command. So it's learning one via it's learning via this interface 0/2. Yep, it's learning via 0/2. Um okay, it's learning via 0/2. That's the direct link, but it's not learning through the ISP link, which was the issue. Over the ISP link is not forming. So it's not learning through this ISP link. So let's see what could be the issue. Let's see what the issue could be over there. So let's do something. We can just show run on these two devices, but let's try it to just compare the OSPF configurations. But let's try a different route rather. So let's try to run some debugs. OSPF. This is an adjacency stuff, right? So let's try the adjacency. So we are trying to debug OSPF adjacency. I think we are getting something immediately. Mismatched authentication key. Tell me something. Let's see. Let's see what's going on. Let's see what's going on. So let's check here. Show 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 run. What's the interface? 0/1. 0/1. So we see this is the authentication. It's using message digest and the key is one. The password is foundation. Let's check the HQ router. Show run. I think I've passed that. Oh, I've not gotten to it. I've not gotten to it. And we see it's using message direct, which is fine. The password is foundation, but the key is 2. So I believe this is the issue. So let's make the key consistent. Let's make the keys consistent. Int interface 0/1 and IP OSPF message digest key 1, MD5 foundation. And let's see if that can resolve this issue. Okay, so we see it has gone to done. It has gone to full. It has gone to full. So let's show IP OSPF neighbor again, and we see we can learn the two of them right now. We can learn the two of them. So let's just turn off our debug. What command? Debug. Debug OSPF. Hmm? No debug. No debug IP OSPF adjacency, right? Okay, so that's fine. That's fine. So I believe we fixed this issue. We fixed this issue. The adjacency is now up between those links. Now, the new backup link between the routers is physically up. That's this guy. This is a new backup link. But a check of the interface counter shows a high number of errors and collisions, causing adjacencies to flag. Diagnosis layer 1 issue. So this is between HQ router and branch router E002, E0/2. So let's just see what's going on that interface. E0/2. Right. Yep. Do show run. Do show run E0/2. Okay. Mm, I'm unable to find any issue here. Okay, let's do show interface E0/2. Show interface E0/2. And we can't really find errors. So I believe this question was written here, but I forgot to effect the actual error. I forgot to configure the actual error on on these devices. So so sorry about that. So sorry about that. So for this issue, there is no issue here for prompt 2.2. For prompt 2.2, I can't find the issues here. So I believe I forgot to configure the. I forgot to set the issues there. Okay. So what I had in mind was probably to set duplex to maybe half on one side and maybe full on the other side or something similar to that. I can't really remember, but I believe that's what I should have in mind. Okay, so 2.3, despite having two parts, oh yeah, there are two parts now. There are two parts. This part over the ISP, which in this case is more reliable. This one is just the backup link that the engineer added to solve this issue, but it's now causing so many other issues. So despite having two parts, network traffic is behaving suboptimally, with a significant portion of packets being sent down the slow backup link. Oh wow, really? Let's see. Let's see. Let's see. Um, do show IP. Do show IP routes. Hmm. hmm. Do show IP OSPF neighbor. So we see we have our two neighbors. We have our OSPF connection set up. But now, for this HQ to get to 192.168.20 network, it's supposed to use OSPF, right? We need it to use OSPF, right? 20 network. Is it 20? No, I think it's 10. Let's see. What network is the branch? Oh, the branch is 10. So for it to get to this, where is that? The HQ router. Yep. For it to get to this, it's supposed to use OSPF. That's what we want it to use. But it's using static route 172.16.2.1. Who is that? Do show IP interface brief. That is 2.1, right? So that is this link E02. That is the backup link. The backup link. So we see this static route is probably misconfigured, forcing all traffic. Our OSPF is fine now, but static route has a better preference. One, right? It has a better preference one than OSPF. So you see, OSPF is 110. So it's going to prefer the static route. It's going to install the static route into the routing table and just ignore the OSPF. So let's remove this static route. Do show run. So no, where is that? This right here. Okay, so that should be fine now. So let's check our route again, and we should be learning that network via OSPF, and this is what we want, or maybe not. Okay, so now we see we are learning this via OSPF now via the both links, the two links. But let's see. Additionally, so we fixed one section of this prompt. So we fixed fault one. Now let's see. Additionally, trace route shows a confusing non-optimal path. Audit the L3 path selection mechanisms on both the routers and implement fixes to ensure the primary link is always preferred and the routing is symmetric. So the routing is symmetric. So it is going out from here. It is going out maybe from here. Um, Going out maybe like this and also coming in this way. But for asymmetric routing, it can be going out this way and trying to come in this way. There are situations where we might want to implement that, but most times if you do not plan it properly, it will cause issues. It will cause issues. And for this, we want it to be symmetric. So how do we do that? We know we can fix this in OSPF by using costs, right? We can do this by using costs. So let's see what we have and what we can do. Do show run. Um, do show run. Do show run. Okay, this is the backup link and this is the main link. Let's check on the branch also. Show run. This is the backup link and this is the main link. I think this branch is trying to do something. It's trying to modify the cost. It's trying to modify the cost here, but it's giving it it's setting it to OSPF version 3. I think this should be OSPF since we did not configure OSPF version 3. So I think the admin or the engineer was trying to modify this cost, but ended up setting OSPF version 3. No OSPF version 3 cost. So let's try okay, I think that should be IP OSPF, right? Yep. IP OSPF cost. Should it interface E0/2 IP OSPF costs 100. And now let's check our routes again. Let's just wait. Let's just wait a few seconds. Okay, so this is fine now. So we can see it is only selecting um this part. And let's check on this end also. Do show IP routes, right? It is only selecting this part, interface E0/1. So if this part fails, that is when these other parts would be populated on the routing table. So this is just a way of configuring I think it's called floating routes, right? Floating static routes. So if this part fails, then the backup link will kick up. Okay, so that's fine. So I believe we've covered this. Next. Okay, so we have the next prompt right here. An audit of the OSP database reveals that a critical 32 prefix is missing. Identify this misconfiguration on the branch router. So we're on the branch router. Let's check for that. The flash 32. I believe that should be the loopback, but the configuration right here is fine. So let's check OSPF itself. Oh yeah, and we are seeing passive interface on the branch router here. So I believe that shouldn't be there. So let's remove that. Let's remove that. No passive interface, loopback 0. No passive interface, loopback 0, and that should fix that. Okay, so next from 3.2, we have the network clock on branch router is not synchronized. Diagnose the NTP configuration and resolve the issue. NTP. So let's see. Show NTP Okay, let's check the associations. I think we're having 3.3. Let's see what what do we check? Do show NTP association. So we are having this. Well, let's see what we are having here in the configuration on the branch router interface E0/0. Uh, okay, I think the issue is just this source. It's just this source. Even with this source, it is still forming because this source is still reachable over the network. If we check others, I believe if we check this, it should be using maybe a loopback, which is like the better way to do it, to do that. Because now, if this interface goes down on this branch router, if the interface goes down, the NTP won't be synchronized. So let's check how this guy is doing it. And this is not even stating a source. Let's check. Let's check others. Let's check others. Okay, this is using VLAN 20, which is fine, which is like it's available. It's like the only available type in this instance. So, by the way, best practice is to use the loopback. Is to use the loopback. So let's remove this E00 so that if this interface goes down, we can still have something that can do that. So um, loopback 0. Okay, so that's fine. That's fine. So that would fix 3.2. From 3.3 says users in the branch are reporting that they can access most internal services but cannot reach a specific server. An outbound ACL is suspected. Find and fix this issue. So this is the branch router. Um, if we check, we have an ACL here. Well, the server is permitted. The server is permitted, but there's a broad deny ACL on top of it right here. There's a broad deny ACL on top of it here. So we can try to fix this. We can try to fix, but let's see where it is bound. It is bound on E000 right here. Right here. For this, I'm just going to quickly remove that ACL there. And before we do this, we can recall that our branch switch could not ping the branch router earlier. So we see it is still unreachable, 0 of 5. So after fixing this, I believe that issue should be resolved. Yeah, so now it can ping. It can ping. Then one more thing, let's check our branch PC now if it can get DHCP. It's not finding it. Let's try again. It can't find it. Why? Let's see what's going on. Let's see what's going on. What's the DHCP server? Show run this right. Let's see if we can reach it. We can reach it. So this should work. This should work. What could the issue be? What could the issue be? What could the issue be? Mm, just to verify, um, this is on access 10. This is on access. Now, since this is ultimately not working, um, checking the HQ router, the configuration looks fine. The HQ router can reach the branch switch. The branch switch can reach the HQ router, and the DHCP configuration on the HQ router is also looking fine. Look at the branch; it's looking fine. So one thing that came to my mind. In fact, when I was creating this challenge, I didn't think about this, but let's try it. Let's try it. Where is the VACL? Okay, so let's see what this is doing. Let's see what this is doing. So we have the VLAN filter VACL map to VLAN list 10, VLAN 10. And we have the ACL map right here. It is matching IP address in this VACL filter, and it is forwarding that. That means it will not forward any other time. So let's see if we can modify the IP addresses in this VACL filter. Okay, so let's do this. Permits. Let's try any. Do show run. Okay, since any is here, that we can add the other IP address. Yeah, let's try this again. Oh wow, beautiful. So using this gotten IP, let's see if we can reach with Let's see if we can reach the HQ. That should be 20.1, and yes, we can. The host is 20.2, and we can. So for the verification, provide outputs of branch from the branch PC to ping of branch PC to HQ PC, and so that's what we did now. Then show the output of show IP route from the branch router. Um, show IP route. So of course, here we do not expect to see the backup from this command. We do not expect to see the backup from this command. So I think this is fine. This is fine. This is fine, and this is the end of for this lab. Thank you so much everyone for joining this. We'll see you in the next challenge. Thank you and bye.